We're going to look at some more examples of how to solve a system of equations using specifically the linear combinations method. Sometimes this method is referred to as the elimination method, which you'll see the reason why when we're doing this example. So in order to use a linear combinations method, it's best to check first to see that the like terms are lined up. So you can check your equations, your 2x and your 2x are lined up. That's good. The 3y and the 7y are lined up, and then the 4 and the 16 are lined up, and the equal signs are lined up. So everything's lined up. All of our like terms are lined up vertically. So that's good. So now what we have to do is check to see if there's any opposite terms in the equations. If we don't have opposite terms, we have to create them. So let's look. I have a 2x and a negative 2x. Those are opposite terms. So that's good. I have opposite terms. My third step would be to add the equations. And this is where the linear combinations method gets its nickname, the elimination method, because when I add 2x and negative 2x, those terms eliminate. And that's good because that means that our equation now only involves one variable. 4 plus 16 is 20. So now I have just one variable. I just have a y, and I can divide by 10 and get my value for y. Finally, the last step would be to use step 4 to solve for the other variable. So I know what y is equal to, but I also need to know what my x is equal to. So let's go ahead and take one of our original equations. It doesn't matter which one you choose. I'm going to choose the top equation, and I'm just going to substitute this value in for my y. So now I have 2 times x plus 3 times 2 is 6. And now I can solve my x value. So I have x is -1 and y is 2. This is an ordered pair. And you can check on the graph. If you were to graph this equation and this equation, they should cross each other at this point, -1, 2. And I can see on my graph that sure enough, they cross each other at that point. So I know that my solution is correct. And then we'll do one more example. Let's look through steps again. We're going to check that ours are lined up. Then we're going to check to see if we have opposite terms. If we don't have opposite terms, we're going to have to create them, and I'll show you how to do that. Once we have opposite terms, we're going to add the equations to eliminate a variable, solve for that variable,